Hi, welcome to the third topic of the Climate Match Academy. I'm Dr. Rao. The topic for today is remote sensing. In this topic, we'll cover the basic of satellite remote sensing and how to find the remote sensing data for climate applications and how to use remote sensing data for climate applications. In this first module, we will cover the topic of what remote sensing is and different applications of it. By definition, remote sensing is a technique of retrieving information remotely or from a distance. It is actually very common in our daily life. Some most common examples include photography and remote controls. Although it is common in our daily life, the remote sensing we are referring to in Earth and climate sciences often means satellite and airborne remote sensing. The bottom left animation displays how a sensor on board a geostationary satellite scans in North America every 5 minutes. The middle image is a NASA airplane used to measure the snow and the glacier in the Greenland and Arctic region. We can also use sensors on the International Space Station on the bottom right to collect information about Earth, like the bottom right image. The foundation of remote sensing is the electromagnetic spectrum, a physics concept that is used in the design of every satellite remote sensing sensors. It describes the range of energy that travels in the world. Different parts of the spectrum can be used for different applications, such as radio stations, cell phone communication, X-rays, and microwave ovens. For remote sensing, we often use different parts of the spectrum for different earth science applications. We can use visible channel to study the change of vegetation and the surface of the land. We can use the thermal infrared channels to study the change of temperature over both land and ocean. We can use microwave range to study water availability. There are many more examples that you can explore in the future. Since the launch of the first weather satellites, TIRAS, in 1960, scientists have been using satellites to monitor the environment operationally for more than 40 years. The early generation of satellites were mostly designed to monitor the change of clouds for weather prediction. But new technologies allow us to use different aspects of land, ocean, atmosphere using satellites. The left image shows a list of Earth-observing satellites that's operated by NASA and its partners. Other space agencies, such as European Space Agency and Japanese Meteorological Agency, also have similar capacities to operate and develop these satellites. The diversity of different satellites and the remote sensors on board these satellites gives us a unique opportunity to study the change in our Earth system that humans cannot observe or reach. A geostationary satellite can help us track 6 tropical storms at the same time as shown on the left side. With satellite data, we can use it for different types of climate applications. Like mentioned before, visible and near-infrared sensors in the electromagnetic spectrum can be used to study vegetation dynamics and in response to the climate change. The thermal spectrum sensors can be used to monitor the temperature change over the land and ocean surface, as well as across different levels of the atmosphere, while the microwave sensors can be used to measure the change of soil moisture and other types of water availability. The bonus of the microwave sensors is that it can also penetrate the cloud, which often obscure the visible and thermal channels. While satellite altimetry data can also help us to monitor the change of sea level, which is another challenge of climate. In this tutorial, you'll learn the key concept of remote sensing, including electromagnetic spectrum, different types of satellite orbits, different resolutions including spatial, temporal, radiometric, and spectral resolutions. You will also understand the value and benefits of satellite remote sensing for climate through selected examples.